Hey guys, we have two problems we're looking at to check our understanding from today's class. Okay, so the first one says, use similar right triangles to find the coordinate of point C located a quarter of the way there, A to B. Okay, so I notice this is 1, 2, 3, 4. Okay, so I like that. That's definitely 4. I notice this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8. Now these are great. They're easy to cut in fourths. So this is easy. This is already cut in fourths. So I can just kind of follow it over, boom. Follow it over, boom. Follow it over, boom. I have cut this line in 4 equal pieces. Notice, boom, 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 boom. 4 equal pieces. Now, to find the point, a quarter of the way there would be here. And they want me to label that point C. So for A, point C is the coordinate, the origin, 0, 0. That's 1/4 of the way there. Next question. B says, using similar triangles, find the coordinate of D if it's 1/6 of the way there. Okay, so 4 divided by 6 is not going to be as easy. 8 divided by 6, same thing. So let's do that in our calculator. So 4 divided by 6 is, 0.6 repeating. 8 divided by 6, 1.3 repeating. So it's not going to be perfect, guys. So this ends up going 2/3 or 0.6 repeating. This ends up being what is this, 4/3 or 1.3 repeating? All right, so if I'm going to cut that in 6 equal pieces, let me start over here. 6 can definitely get cut in half. So I can do that. I can cut this in half, cut the 4 in half, cut the 8 in half. Definitely do that. And now I just need 4 to be cut. So it says each one is 1 1/3. So 1 1/3. And I'll follow that up. And that's now 2/3. So that's 1 1/3. 1 1/3 plus another 1 1/3. 1 1/3 plus another 1 1/3 is 2 2/3. So I have to go 1, 2, and 2/3. Follow that up. All right, so it says, what is 1/6 of the way there? So again, if I kept doing this, 1 1/3, follow that up, and 1, 2, and 2/3, follow that up. Okay, I've done it. I've cut this in 6 equal pieces. Not perfect, but pretty darn close. 1/6 of the way there, B to A. Oh, they tried to trick me. Okay, so I'm looking for this coordinate. And what was that coordinate? It was pretty darn close to. It looks like it went over 4 2/3. So call this point D. I went over 4 2/3. And then 4 2/3. And then it looks like I went up. So how is the vertical cut in half? I've got to think about this. So here it's not, but then see how it went up 2/3? That's 2/3. So it went up from this line at 1. It went up 2/3 and another 2/3. So 2/3 plus 2/3 is 4/3. So that's 1 1/3. Okay, so from that line, it went up 1, 2 boxes, and 1/3. Okay. Last one, use similar right triangles to find the coordinate of point E if it's located 2 out of 3. Okay, so we figured this out last time. That this is a sneaky way of saying if I had 1, 2, 3, 4, 5, I want to go 2 to the left with 3 left to go. So this is asking this location right there. 2 to the left with 3 to the left to go. So we normally would call that 2/5 of the way there. And again, what I'm doing is I'm noticing if I add the two pieces together, they ask me to cut it in 5 pieces. So that number goes there. And 2 is the first number, 2/5 of the way there. Okay, so how can I cut 4 in 5 equal pieces or 8 in 5 equal pieces? I can't very easily. It's not going to be perfect. 4 in 5 equal pieces or 8 in 5 equal pieces. Let's go to the calculator. 4 in 5 equal pieces is 0.8. And 8 in 5 equal pieces, 1.6. Okay. And it looks like I'm going from a this is a typo. This should be E and that should be E. Interesting. Okay. Sorry for that typo. All right, so how do I do that? I've got to go 1 1/3, and I actually have to kind of erase what I have here because I've got to go a different distance. Okay, yeah, okay. So 1.6. 5 I can't cut in half either, so I know it's not going to be right in the middle. Notice this is not right in the middle. Right? So if I have to cut this in 5 equal pieces, I have to go over 1 and a little more than 1.5, 1.6. And then I got to go up, not a whole line, which looks like not a whole line. So that would be the first dot. Then I got to do that again, right? It almost looks like the same slope triangle. I got to go over 1.6. So it's going to be something like that. And I got to go up the same amount. I got to make a dot. And so I can think about doing the same thing and similar triangles. Each of these triangles should be the same. So I'll visually try to make this as visually pleasing as possible. And it looks like, it's not perfect, but it looks like I cut this in 5 equal pieces. So where would this dot be? From A to B, 2/5 of the way there. It looks like I'm pretty much right there. I'm going to guess it's not perfect, right? I know it's not perfect, but it looks like I went over a little bit more than 1, and I went up about 2/3, right? A little bit more than 1. So let's see. I started at -2, and I added 1.6, and then I added another 1.6. So where would that land me? 1.2. Now, vertically, what did I do? Well, let's see. Vertically, I started here at -1, and I added 0.8, and then I added another 0.8. So -2 plus 0.8 plus 0.8. So that means, oh wait, no. I'm here in the y, I'm at -1, -1, -1. So it's 0.6. Okay, so that kind of makes sense. So I end up at not 2/3, but close to 2/3. I end up at 0.6. So I end up finding my coordinate. And again, if you're not exactly there, you should be close to there. And that looks pretty good. All right, now my other assessment talks about my Pythagorean triples. So this is kind of a cool question. I like this. A man has 3 kids, 1, 2, 3. They are not triplets, meaning they're not all the same age. By remarkable coincidence, however, they were all born the same day. So my birthday is August 14th. So imagine they were all born on the same day, but in different years. So they're definitely different ages. By another remarkable coincidence, their ages right now form a Pythagorean triple. The oldest child is 9 years older than the youngest. So if I make this x, this is x plus 9. The middle child is 2 years younger than the oldest. So the middle child is 2 years younger. Okay, so this is than the oldest. So minus 2 years. How old are each of these children? I don't know. In fact, their ages don't have to add up to anything. They just need to be a Pythagorean triple. So if this is x, this person has to be 7 years older, and this sibling has to be 9 years older. Notice the middle child is 2 years younger than the oldest, so that makes sense. So let's try some of ours. Is 3, if I plug in 3 for x, and I'm just trying here, right? Is 3, and then 3 plus 7, I get 10. And then 3 plus 9, I get 12. Is 3, 10, 12 a Pythagorean triple? No. So I think we had one where we had 5, 12, 13. So let's try that out. So if x were 5, and 5 plus 7 is 12, and then 5 plus 9 is 14, not quite. It's close though. So we'll Google, let's see, where's my Google? I can Google Pythagorean triples. I found 2 of the ones we talked about today. And yeah, here's a diagram of some Pythagorean triples. So 7, 24, but that doesn't make sense, right? We need 2 years old. Yeah, 8, 15, 17 looks good. 8, 15, 17. 8. My second class actually came up with that one. 8, and then what is 8? 8 plus 7, that's 15. And yep, and then 2 more years, 8 plus 9, 17. Yeah, so that's it. So one of the children is 8, one is 15, one is 17. Let's say you couldn't Google, because you can't on a test, what would you do? Well, again, you could actually use some algebra for this, because this is a squared, this is b squared, and this is c squared. So we could have gone, the first child has to equal the second child squared plus the third child squared. And this gets really ugly algebra, doesn't it? And I kind of warned you that there'll always be questions that they want to throw some algebra in. And we'll continue to work on this, okay? But when I FOIL this, first term, last term, inside, outside, I get 7x and 7x and 49. Here, same thing, first term, last term, inside, outside. Okay, so I end up getting, let's see how many, on this side, I end up getting 2x squared. And I get 14x, I get 49. On this side, I can combine these two. And then I can start subtracting. Like, notice how I can subtract an x squared, and I just get an x squared, right? Because that's just 1. I can subtract this 18x. I get negative 4x. And I can subtract the 81, and I get negative, what would that be? 81 take away 49. When would this work? Yeah, so I think 8 and 4 is 32. 8 times 4 is 32. And one is negative and one is positive. Yeah, so this is what I get. And notice, I know I'm doing a lot of algebra. This class did come before that, right? If I add 8 on both sides, I notice x can be 8. And x could be negative 4. I'm like, wait, that's not going to work. We can't have a side length. So this is called an extraneous answer. So this is our answer. And we actually found it in class. So this is easier if you memorize a couple of the Pythagorean triples. Kind of cool. Okay, part B, it says the man knows that a multiple of a triple is also a Pythagorean triple. So we explored that as well. A 3, 4, 5 would be the same as a 6, 8, 10. It's just twice as big. Okay? He reasoned that in the year when the ages of his children have doubled, their ages will again form a triple. Is he correct? No, not correct. All right. I think I told you, everyone, I have a brother and he's a year older and another brother is a year older. When this person is 6, they're 3 years older. And so that would make this person 7 and this person 3 years older, 8. So if you're consecutively aged, just 1 year older each time, when the first child's age doubles, the other children's ages won't double. So I'm going to say no. When one child's age doubles, the others won't double. Okay? Well done, guys.